only have 10 days left. So as long as I get a good grade and I pass, I'm good.
It's all that matters.
Yeah.
I had a problem with clicking on
What, to the Zoom meeting or to the recording?
the first Zoom meeting, and so I had to send it real quick to COS.
You were able to straighten it out okay?
Yeah, when they sent it back to me, it was in blue. The link was
Okay, great.
So they were able to send it back.
Yeah, like I said, there were some people in the class who were in fact able to look at yesterday's recording. So I'm going to find out if there's anybody here today and see if they did anything different.
I did not look at yesterday's recording, but because you said today you're really going to dig into the outline.
Correct.
Really
Yeah.
gonna be-
Yeah. Today's going to be the day when you're going to start wanting to pay attention.
Oh no, I thought yesterday was interesting, but I said today is really what I want to hone in on. That was like a meet and greet to me yesterday.
Yeah, I'm a total science nerd. Yeah.
I don't know if it made a difference or not, but like when you send the links, like in past classes, like the Zoom link is highlighted. So you just click on it and then it goes directly to it. But it looks like it's typed in. So I have to copy and paste into a server. I don't know if that makes a difference with the video or not, because
Yeah, you mean it might be missing a character or something?
I'm not sure, because I had no problem putting the link in for our Zoom meeting like this, but the videos won't show up. So I don't know if it has anything to do with like not being able to highlight to click on directly or not. I'm not sure.
Well, from my end, when I want to send you the link, and I obviously I get onto Zoom, and there's a separate page that says my recordings, and they're titled according to what class they are, so I know which one to pull. But then if I merely highlight the class I want, it prompts me with, do you want to share this or do you want to copy this? And I say yes, and it copies it to my clipboard, upon which I paste it to the class email. So that's how it's transferred to your class email. And like you said, paste, that's basically pasting. So it's possible something occurred in the transfer. But we'll see. Is there anybody here right now that actually was able to view the recording?
I was able to.
Ashley, okay, no issues. You just logged right on and typed in the password and that was it?
Yeah.
Wow. Now, when you, did you copy the link and then paste it and then go to the recording?
Yeah, also recommend me the password, which is I copy and paste it also. So it worked just fine.
Okay. All right. Wow. Christine, I can't explain that. I don't know what to say. But if we continue to have an issue, just rest assured, everybody, I will, I already have lecture notes prepared. We just put a new telescope into space this week, everybody. And its purpose in life is to spot potential asteroids that might come close to the Earth. And the telescope is capable of spotting something that is about 400 feet wide. It can't really see much of anything if it's smaller than that. So that may sound strange to you, but you got to remember this is outer space. There's, it's black, and then you're looking for a rock that's black. So, you got to get lucky. And but they just put it up, and if you are ever interested, or if you parents in the room, you want to get your kid interested in this, all these like NASA and everything, they all have these websites that you could log on to and look at the latest telescope images, or it's pretty interesting stuff, because they not only take pictures of asteroids, that we've got satellites orbiting Mars, Jupiter. We had one orbiting Saturn, but we purposely crashed it into the planet. We had one that passed by Pluto out in the outer rim. And we even landed a satellite on an asteroid. This was about 6-7 years ago. And that was pretty amazing. Got to remember that asteroid is moving at multiple speeds of a rifle bullet. And you landed a satellite on it. That's impressive. And there's a good chance that a nearby star is going to explode sometime in the near future. And it's going to be close enough that you will be able to see it with the naked eye. And it will be visible even in the daylight hours. Most of you, I think, are familiar with the constellation called Orion. You've seen that in the night sky. The star that makes up Orion's right shoulder is called a red giant, and the name of the star is Betelgeuse, and it's going to explode. We know that for a fact. We just don't know precisely when. And it's close enough, everybody, that when it does explode, it will look like a full moon to you, even in the daylight sky, for about 2 to 3 weeks. When it explodes, it will be momentarily brighter than the combined light of the entire galaxy. That's a big explosion. Yeah, Betelgeuse, if you were to put it in place of our sun, its radius would go all the way out to almost Saturn. It's a big star. It's about 300 times bigger than our sun.
Why did you say it was going to explode?
Yeah, the really big stars out there, Horace, they live life in the fast lane. They don't live very long. And on a galactic time scale, what that means is these stars only live in the tens of millions of years. Our star is going to live to be about 10 billion years.
I guess we won't have to worry about that in our lifetime.
No. Matter of fact, you should be thankful that as far as our sun is concerned, the gas tank is still 3/4 full. And we've been burning, our sun has been burning hydrogen fuel for the last 4.5 billion years, and it's still 3/4 full. Betelgeuse does all of that in just 10 million years. And the reason it does it so quickly is precisely because of its size. You know, an object that big is exerting a tremendous amount of gravity on the core of that star. And it's basically like putting your foot down on the gas pedal and just going for it. And so the nuclear reactions are happening at a much, much faster rate. So it burns its fuel faster. Even though it has more fuel than our sun, it's burning it a lot faster.
When it explodes, How will it affect the ozone?
Fortunately for us, it's approximately 650 light years away. And we will undoubtedly receive some of the cosmic radiation that it puts out into space, but it shouldn't be enough to affect life on this planet. No. You'd have to be within about 100 light years for that to happen. And then you're right, we might lose our ozone layer. And as whimsical as that might sound to you, everybody, because the ozone in our atmosphere is found in trace quantities. Trace. If we remove the ozone from our atmosphere, humanity dies within about 2 to 3 generations.
Do you believe in global warming?
Oh, wholeheartedly. The problem I think most people have with subjects like global warming is in your mind's eye, in your thinking, you have to expand your thinking. You have to, in your mind's eye, look at the entire Earth itself, not just Visalia, California, or even the state of California. You have to look at the bigger picture. And you have to take into account our relationship to the sun. And then you have to take into account all of the unique variables, such as all the chemicals that make up our atmosphere, because it's not just oxygen and nitrogen. There's dozens of other chemicals in our atmosphere, many of which are necessary for all forms of life to exist on this planet. Then you have a planet Earth that is covered mostly in water. And the oceans on our planet, everybody, have a chemistry to them. Some of you may have heard already, or maybe even you know this already. The salinity value of our oceans worldwide, no matter where you go, take a sample of water, boom, it's 7.5% salt solution. That's consistent. How does that affect global warming? Let me tell you something here. What boils faster, fresh water or salt water? Now, all of a sudden, let's just say the temperatures on the planet start rising and all the ice on the planet starts melting. Rising sea levels are going to be the least of your worries. You are now dumping millions upon millions upon millions of gallons of fresh water into an ocean whose salinity value is now going to be altered because of that. And it's going to alter how water evaporates into the atmosphere, which is going to change climate patterns. My issue with climate, global warming is I believe in it, yes. I just don't believe we understand completely all the different variables that are at play in this subject. There's more than just humans putting smog into the atmosphere, even though, yes, that's a contributing factor, but there's so much more to it. And we don't understand completely what the end results are going to be precisely because of all these variables. So when you see somebody get on the news and start talking about global warming, the moment they say something like, well, the ice sheets are melting, I've lost them already. I'm not interested in what they have to say, because it seems to me like that person's focused on that one thing that is going to make global warming a real phenomenon. And when you look at the planet as a whole, everybody, Earth has gone through many different periods of global warming and complete freeze over. Our planet has been a huge ice cube on several occasions. And we have physical proof that it actually was. So in a way, this global warming issue that we're going through now is another part of the cycle of life on planet Earth. The difference is humans are here now. The planet has been here for 4.5 billion years. Homo sapiens been here. If you ask an anthropologist, the oldest number I've ever heard is 100,000 years. Do the math, 4.5 billion, and then we're here for 100,000. We have some more research to do.
So I've heard it, clean energy is the way to go, but do you think that's just a part of it?
Definitely clean energy. And there is a movement towards that right now with all the electric vehicles you are witnessing on the car lots now and in parking lots. And I know many of you have seen those recharging stations located in shopping mall parking lots. That to me strikes me as a little weird. That's going to change. Here's what I see in the future, everybody. And this is why the transition to clean power is not going to happen overnight. You see, let's just say you had a magic wand and you wanted to get rid of all the fossil fuels on the planet. All right, boom, they're not here anymore. Well, you now have to completely dismantle the infrastructure that was supporting a fossil fuel driven economy. So therefore, all the gas stations got to go. Everything related to oil and natural gas has to go because we don't need it anymore. We have to replace that entire infrastructure with, let's just say, hydrogen fuel. So instead of going to a gas station, you're going to a hydrogen station. But it all has to be changed. And that's going to take your tax dollar to do that. So all of these mom and pop 7-Eleven / liquor store / gas stations all got to go. Every one of them, because the infrastructure is going to switch over to alternative fuels. And the ultimate goal, and I don't think this is going to happen for a couple of generations yet, but the cleanest form of energy that we know of that we might have the ability to actually produce is something called cold fusion. You see, the process that creates energy inside the sun is called fusion. You take 2 atoms of hydrogen, you slam them together real hard, and that's fusion. It releases energy. By itself, those 2 atoms don't release a tremendous amount of energy. But for those of you that remember your high school chemistry, do you remember Avogadro's number? For those of you who have taken a chemistry class, Mr. Avogadro discovered, and he did this in the late 1800s, by the way. This is amazing stuff. In the world of chemistry, everybody, when you measure something, there are standard units of measure so that when you experiment with something, the guy in another country wants to duplicate that experiment. He knows precisely how much of whatever it was you used because there's standard units of measurement. One of those is called a mole. It's a very small amount of any given substance. Doesn't care what it is. 1 mole of it is a small, it's maybe less than the size of a pinhead. Mr. Avogadro figured out that no matter what the substance is, if you have a mole of that substance, there are pretty close to 6 × 10⁻³ power atoms in that single mole. And you've got all of these hydrogen atoms colliding with each other, each of them releasing a small amount of energy, but now you got trillions and trillions and trillions of them doing that. Yes, you get the big kaboom. We want to be able to duplicate that process without having to create the high temperatures. See, fusion only occurs with hydrogen at temperatures in the 18 million degree range. We've not been able to create an oven on Earth that can create temperatures that high. So we are trying to figure out a way to fuse 2 atoms together at room temperature. I don't think that's going to happen for probably the next couple of generations. But if we figure it out, everybody, it's absolutely clean energy. There's no radiation side effects from that that particular form of fusion. You see, what we do here on planet Earth, when the state of California has 2 nuclear power plants, and they create energy by a process called fission. It's the exact opposite of fusion. Instead of joining 2 atoms in our nuclear reactors, we split 1 atom. It creates energy, but unfortunately, it also creates a lot of bad side effects too. The radiation is what I'm talking about. So obviously, we want to move away from that form of energy, but right now, that's all we got. That's all we have. Okay, I think everybody that's going to be here is here.
Recording in progress.
Okay, so if you have time, everybody, just before class started, I sent out a message with a PDF file that contains a handout for this section of material here, okay? And it's titled The Earth-Sun Relationship, okay? If you haven't had time to look at your email and possibly print it out, don't worry about it. You'll be able to keep up, okay? But anyway, on the study guide here, there's some basics I want you to know for exam 1 here, and it's listed on the study guide. It's listed under number 1 where it says size, shape, and features of the Earth, okay? So that's the subject I want to bring up right now, okay? That's what I want to cover now. So in terms of Earth's dimensions, there's 2 dimensions I want you to know. How big around are we? How wide are we? Okay. Earth is 24,000 miles around. That's our circumference. We are, and I'm rounding this off, by the way, it's actually slightly less than this, but Earth is 8,000 miles wide, or Earth's diameter is 8,000 miles. It's actually closer to like 7,950, but who's counting? Anyway, as simple as those 2 numbers might seem to you, everybody, it's not, it's going to take humanity, oh gosh, I'd say we did not realize that the Earth was round, and we did not realize that it was 24,000 miles around until the mid-1500s. I mean, how long has humanity been here? And it takes us until about the year 1520 or 1530 to figure out that the Earth is really big and it's 24,000 miles around. The person responsible for that, by the way, it's not a test question, everybody, but just the person responsible for that is a Portuguese explorer by the name of Ferdinand Magellan. He's the first navigator that actually went completely around the Earth. When he took off on his voyage, everybody, that was his purpose. But he had another purpose as well. He was commissioned by keep in mind, he's Portuguese. He's commissioned by the King of Spain. In the 1500s, Spain and Portugal did not get along with each other. They didn't like each other. So the Spanish king is hiring a Portuguese sailor to fly the Spanish flag. And what does he want him to do? I want you to sail across the Atlantic Ocean. I want you to hug the South American coastline, and I want you to look for a waterway that will allow you to sail all the way through the Americas and come out the other side. And they expected the country of India to be right on the other side. Now, you've seen maps of North and South America. There's no rivers crossing the length of the continents to go from one side to the other. The country of Panama is about as thin as it gets. So there's where the canal is. But in 1500, no. So Magellan's going to follow the coastline, and he's going to go all the way underneath South America. And what's so amazing about this, everybody, is he's sailing on ships that nails have not been invented yet. These ships are held together with horsehide and glue. And he's sailing down here. A very long voyage in his lifetime would have been about 3 months. The sailors on the boat would be ready for mutiny after 3 months. Let's go home. Let's go to, I want dry land, that kind of thing. By the time he gets down towards the southern end of South America, he's been at sea now for nearly 9 months. The crew is starting to get a little cabin fever here. In addition to this, everybody, when you sail completely under South America, you are only about 700 miles away from Antarctica. They're seeing icebergs for the very first time. They come out the other end. They're now in the Pacific Ocean. They've gone all the way underneath South America. Now, you've seen pictures of the Pacific Ocean. There's not a lot of dry land out there, is there? He comes out from underneath South America and he has no clue that he's not even halfway through his voyage because he still has to cross the Pacific. The Pacific Ocean, everybody, is the single largest feature on Earth. You can fit every square inch of dry land in the Pacific Ocean and still have 6 million square miles of water left over. The United States total, all 50 states, are 3.6 million square miles. That means you can almost fit 2 complete United States left over in what's left over in the water. And Magellan has to cross this in a little 280-foot long boat held together by horsehide and glue. The fact that he made it is absolutely remarkable. But of course, as you know, he landed in the Philippines. And so what do you think a popular male name in the Philippines is today, by the way, everybody? Have you met anybody from the Philippines named Ferdinand? A lot of Filipinos admire him for bringing Christianity to the Philippines. So in honor, they named their kids Ferdinand. Anyway, so the Earth is 24,000 miles around, 8,000 miles wide. That number 24,000 is also a bit serendipitous, everybody. And what I mean by that is just a fluke of nature that it turned out that way, because as another fluke of nature, how long does it take us to rotate once on our axis? Well, 24 hours. How convenient is that? We're 24,000 miles around and it takes us 24 hours to rotate once on our axis. What this means is, everybody, Earth is rotating at 1,000 miles an hour. And you have absolutely no sensation of that at all, precisely because everything on the planet is rotating at 1,000 miles an hour. So it's like the two of you are falling off the cliff at the same speed and you're looking at each other, having a conversation while you're falling. Is that weird or what? If you suddenly stop the planet from rotating, think about this, everybody, you'd now have 1,000 mile an hour winds, because the atmosphere would continue to rotate. And all of a sudden, boom, 1,000 mile an hour wind. The worst hurricanes on Earth generate speeds in the 200 mile an hour range. Now you got 1,000 miles. The strongest building on Earth isn't going to stand up to that. So it's 24,000. We rotate once every 24 hours, 8,000 miles wide. Also, everybody, as we rotate, most of the surface of Earth is covered in water. We rotate toward the east. So from your perspective in Visalia or Hanford or wherever you happen to be, everybody, the Earth rotates in the direction of the Sierra Nevada mountains to the east of you. It makes the sun appear to come up in the east and then set in the west. Okay. And as we rotate, I know I've explained this yesterday, but you'll need to know this for exam 1. As we rotate toward the east, the water located at the equator is going to start moving in a westward direction, opposite of the Earth's spin. And as that water current crashes into South America, it's going to divide. And so what I need you to know, everybody, is that ocean currents in the northern hemisphere are going to rotate clockwise. ocean currents in the southern hemisphere will rotate counterclockwise. Okay? And I want you to know this for also another reason, everybody, because it's important to understand. It goes to the topic when I talked about the chemistry of the oceans. We get a continuous stream of solar energy from the sun. The sun never turns off, everybody. It's constantly shining down on this earth. Now, you may not see it for 12 hours out of a day because it's nighttime, but at some place on the earth, it's just blaring sunlight. And most of the surface of Earth is covered in water. Water likes to hang on to energy. If you heat a pot of water and then let it sit at room temperature, it may take it about 30 minutes or more before it finally cools down to room temperature. It does so slowly. And so you have water that is receiving the most intense amounts of solar radiation at the equator. So the water at the equator is really warm. It's probably like bath water if you were to jump into. As a matter of fact, I've been to Miami Beach on a couple of occasions, and I don't like swimming in Miami Beach because the water is like bath water. It really is. It's not refreshing. You feel like I got to take a nap. That's how warm the water is. Now, as this water comes up from the equator and starts passing by all those Caribbean islands on its way towards Florida and then up the east coast of the United States, it's slowly giving up that heat energy. And so it's important to understand rotation in the north goes clockwise. Rotation in the south is counterclockwise. And the reason it's important, everybody, is because the temperature of the ocean water that is off of your coast is going to heavily influence what the weather is in your location. So for instance, the state of Florida, that's really warm water that is passing by the state. Well, think about what the ecosystem in Florida looks like. It's an Everglade. We have cold water coming down the coast of California from Alaska. I don't remember anybody ever telling me, oh yeah, we went to Monterey and swam in our birthday suits. Didn't happen. Because the water temperature is in the 60-degree range. And 60-degree water does not evaporate near as easily as 80-degree water. So we don't get near the amount of rain that Florida gets because of the cold water off the coast of California. Okay, so it's important to understand the rotation, the ocean current that you happen to be living near, because something else that cold water off the coast of California does, and it only does this to the coastal region itself. It does not do this to Visalia or Fresno or Hanford. In the summertime, this Friday, the weather guy says it's going to be 112 degrees. Well, somewhere on the coast of California, it's probably only going to get up to about 90 degrees. In the wintertime, you've all lived here long enough. You've been here on a 30-degree day. It's happened. Not very often, fortunately, but it does. And on those cold weekends, where do you typically go to warm up a little bit? You go to the coast, because in Monterey, it may be 45 degrees, not 30 degrees. And so what this means is, in a place like Monterey, the extreme high temperature and the extreme low temperature, the range is not very far. It's only like 45 degrees up to 90 degrees. That's a 45-degree change in temperature from winter to summer. And that's mild, everybody. And why is that? Because you've got this constant cold water current passing by. It's regulating the temperature. We do not live near a large body of water. And so we have these wild fluctuations in our temperature. If you were ever to pay attention to the change in temperature at a place like Kansas City, everybody, you would see in the wintertime, they'd easily go down to -20, -30 when you add in the wind chill factor. Yet in the summertime, they get up to 95 with 90% humidity. Go figure. They're not near a large body of water. So it's important to understand the ocean current, the rotation, the fact that one current is cold, one current is warm. It really affects the local climate in that ecosystem, okay? Land distribution. I'm going to combine this with land-water ratio, everybody. During the age of exploration, when people like Columbus and Juan Pizarro and Hernan Cortez were discovering these new lands, not only did they not know the true size of the earth or the shape of it they didn't know what the geography of the planet was. You got to remember, the Americas hit them like a ton of bricks. They had absolutely no clue that these continents even existed. And when they were first discovered, it absolutely dumbfounded them. Because you got to remember, in this time period, everybody, the Catholic Church, which is dictating the lives of people at that time period, everybody, the Catholic Church knows everything. The earth is just so big, we are the center of the universe. And the fact that there's a continent out there way bigger than Europe, it ain't happening. And yet there it is. It's going to take these explorers about 100 to 150 years to finally map out somewhat accurately the true size and shape of the various continents, because they didn't know where everything was in relation to each other. And they didn't know what the shapes of these continents were. Okay, so it's going to take them nearly 150 years to do that. And when they compile all of this information, they look at a globe, and you got to remember, everybody, mathematics in this time period is probably at the level of 8th grade geometry. And when they look at a globe, and you have to admit, even today, when you're sitting in a class and you look at a globe, have you noticed that most of the dry land on the planet is located north of the equator? It is. Most of the dry land is north of the equator. Now, the whole idea that the earth was not the center of the universe and that the earth is in fact round, not being held up by 4 elephants on a flat plate, no. There were still quite a few members within the church, and quite a few even not just theologians, but scientists who were still not completely convinced that the earth was round and this was the true size and shape of everything. They weren't convinced of that yet. They thought there was something wrong with the data or something like this. And here was one of their arguments, everybody. Okay, Mr. Smarty Pants, you're telling me that the earth is not the center of the universe. We are just another ordinary planet orbiting around the sun, and we rotate on an axis, which gives us the illusion that the sun is moving over our head. When, we within the church, we've been told by Aristotle and God himself how things really work, and heaven is above, hell is below, and here we are in between, and now you're upsetting the apple cart. Okay, Mr. Smarty Pants, if the earth really is rotating, and you're telling me also that most of the dry land is located north of the equator, what is keeping us from toppling over? Like a child's top when you spin it on the kitchen table and then it starts to get wobbly and fall over. Okay, why hasn't the earth done that yet? They speculated that there must be a counterweight at the bottom half of the earth that is holding us upright. And this is where they dipped into Christian mythology. Within Christian mythology, everybody, there's a story of Jerusalem that involves King Solomon. King Solomon is the son of David. You know, David slew the Goliath, the giant, that kind of thing. David is the first king of Israel. His son takes over. Solomon is in charge. The city is being invaded, and there's going to be an episode in its history where the temple itself is actually destroyed. The Temple of Jerusalem has been destroyed on a number of occasions throughout history. So the one you're looking at today on the 6 o'clock news is not the original. It's old, but it's not the original, okay? Well, this invasion under King Solomon takes place sometime in the 900 BC range. And according to Christian mythology, before the invading armies were actually able to penetrate and get into the Temple of Jerusalem, Solomon had smuggled all of the possessions out of the temple, because the temple was supposed to contain the sum total of wealth of the Jewish state. And it was also supposed to contain all of the various artifacts that you are familiar with from your lessons in the Bible, such as the Ark of the Covenant, the actual staff that Moses carried with him on the Exodus through the desert. So there was artifacts in there as well as gold. And they speculated that because in the 1500s, everybody, the single heaviest element that mankind was aware of was gold. Today, there are 92 naturally occurring elements on the chemical periodic table, plus about 20 man-made ones. So if you look at a modern chemical periodic table, it actually goes up to about 118. There's only 92 naturally occurring ones. After that, they're all man-made. But in the 1500s, they were only aware of about 20 of these elements. And the heaviest of the bunch was easily gold. So they theorized that the earth is being held upright by the hidden gold of King Solomon's mines. And so a Spanish explorer by the name of Cuellar takes it upon him to go on a mission. He searches the Pacific Ocean in the southern hemisphere looking for these mysterious mines that don't exist, but he was looking for them. He's going to spend 20 years of his adult life in the Pacific Ocean looking for the mines. And after 20 years, he finally comes to the conclusion, this is bullshit, I'm going home. He does so on a particular group of islands in the South Pacific that he christened, and to this day they are known as the Solomon Islands. And many of you in this class probably have family members that fought in World War II. That was the site of a famous battle. Anyway, so what I want you to know about land distribution is most of it's located in the north. And it's not being held up by gold. Land-water ratio. The total surface area, and this is not a test question, by the way, but the total surface area of the Earth is approximately, I want to say 197 million square miles. That's the total surface area of the Earth. The total surface area of the dry land on the planet, however, is only 57 million square miles. And when you do a simple division of numbers here, everybody, what you come up with is a ratio. 70.6% of Earth is covered in water. Only 29.4% of the surface of Earth is dry land. And most of that is located in the north. Also, everybody, this is the other reason when Horace asked me earlier about global warming. Here's another variable for you, Horace. Most of the dry land is located in the north. The fact that most of the dry land is located in the north drastically alters climate patterns in the north as opposed to the south. And what I mean by that is that when wind passes over dry land, dry land has the effect of acting like a speed bump to the wind. It slows it down. It acts like friction. The air has to pass over these mountain ranges, so it slows the wind down. You go down to the southern hemisphere, there's not a whole lot of dry land down there, so there's nothing to slow the wind down. The wind patterns in the southern half of Earth are a lot faster than they are up here. And that fact alone heavily influences weather patterns and ecosystems on the southern half of the planet. So once again, lots of variables here. Lots of variables. We just don't have the big picture yet, okay? So what I want you to know is 70.6% of Earth is covered in water. 29.4% is dry land, okay? I'm moving on to number 2, where it says orbital characteristics. This is the handout that I sent you in a PDF file. If you don't have it printed out right now, don't worry about it. You'll be able to print it later and look at your notes, or maybe when you get this recording, it'll make more sense to you. But what I'm talking about here in the Earth-Sun relationship, everybody, is I need to describe to you first some of the characteristics of how the Earth goes around the sun and what that means to our weather, okay? When you were in elementary school, no doubt, you were told that Earth is 93 million miles away from the sun. And that is pretty accurate, not exactly, but it's close enough. We are 93 million miles away from the sun. And you've also been told by me, the Earth goes around the sun. So if you will, in your imagination, everybody, the sun is the center of a large circle. And the Earth is going around the center. And the distance between Earth and sun, the 93 million miles, that would be the radius of that big circle. Now it's a matter of simple algebra. You want to know what the circumference of that circle is. In other words, how big around is Earth's orbit around the sun? Well, according to algebra here, everybody, the circumference of a circle is nothing more than pi times the diameter. Well, you have a radius of 93 million, which means the diameter is 2 times that number. So you have 186 million miles diameter multiplied by pi. And that number comes out to be 587 million miles. So what this means, everybody, is from one birthday to the next, you personally moved 587 million miles. To cover that distance in 365 days, everybody, we are moving really fast. So it's a matter of simple arithmetic after this. It takes Earth 365 days to cover a distance of 587 million miles. So if you take 587 and divide it by 365, what you come up with is, in a single day, from breakfast to breakfast, everybody, you moved 1.6 million miles. There's no sports car on Earth that can move that fast. If you take 1.6 million and divide it by 24, you find out that Earth is going around the sun at a speed of 66,700 miles an hour. We are moving through space at 10 times the speed of a rifle bullet. I get dizzy just thinking about that. And we're rotating at 1,000 miles an hour. That'd be like standing in the back of a pickup truck doing 300 miles an hour, and you are standing in the bed of the pickup truck, pirouetting, spinning at 1,000 miles an hour. I get sick just thinking about it. Another curious fact, again, these numbers don't mean anything to you because you don't have any sensation of them. We currently, well, I believe it's still orbiting. We have a satellite going around Jupiter. You're already aware of the fact that it's the biggest planet in the solar system, and it is. It's 1,000 times bigger than Earth. 1,000 times bigger than Earth. And it rotates on its axis once every 10 hours. That planet is 1,000 times bigger than Earth, and it's rotating at about 80,000 miles an hour. Is that insane or what? This is why Jupiter has that colorful look to it. When parts of the atmosphere rise up and they get to the part where we can actually see it, the rotation smears it out. And so you end up with whatever chemicals are coming up through that atmosphere are being smeared by the rotation. And so you get this pretty looking Van Gogh type painting. It's pretty cool stuff. Anyway, so we are going around the Earth, our Earth-Sun relationship, everybody. We do not go around the sun in a perfect circle. Our orbit is slightly elliptical. And because it's an ellipse, that means at some time during the year, we are physically further away from the sun, and at another time of the year, we are physically closer to the sun. Please pay attention, everybody. We are physically farthest from the sun on July 3rd. We are physically closest to the sun on January 3rd. So why is it so hot in the summertime and yet we're supposed to be further away? And why is it so cold in the wintertime when we are supposed to be so much closer? Well, the difference between the point in time in which we are closest compared to when we are furthest, the difference is 3 million miles. So when we are closest, Earth is 91.5 million miles from the sun. When we are farthest, we are 94.5 million miles. That's a 3 million mile difference. The average between those two numbers is 93 million. And that's what you were taught in elementary school. Now, 3 million miles to you and me personally is a hell of a long distance, but on a galactic scale, it's absolutely nothing. It means nothing. What matters most about your change in seasons, everybody, is not the changing distance to the sun. It's the angle at which you receive solar energy. That is what determines the season you're in. So these are the orbital characteristics I'm going to explain in this section of material. The angle at which you receive solar energy is referred to as a solar angle. And to give you some idea of what I'm talking about, I'm going to give you an example right now. Most of you, I think, are familiar with the idea of an equinox, correct? It occurs in the month of March and it occurs in the month of September. Specifically, I believe it's March 21st and September 21st. It's the beginning of the seasons too, everybody. Our seasons change on the 21st of every 3 months. So winter starts on December 21st. Spring starts on March 21st. Summer starts on June 21st. Summer is our longest day of the year, and we refer to that as the summer solstice. December 21st is our shortest day of the year, and we call that the winter solstice. Then you have March and September, everybody. March 21st and September 21st. Both of those are referred to as equinoxes. And in the case of March, it's the vernal equinox, and in the fall, it's the autumnal equinox. What exactly does that mean, and how does it relate to Visalia? On March 21st, everybody, as we go around the Earth, the sun appears to move. And I don't mean just move over the sky as in a single day. Here's what I mean by that. On any given day of the year, at some place on this earth, the sun is shining at a direct 90-degree angle over the surface of the earth. Okay? On March 21st, the sun is directly over the equator. This is where the name equinox comes in. The sun is directly over the equator, and the entire planet gets a 12-hour day and a 12-hour night. That's what equinox means. It happens on September 21st as well. Okay? You are located in Visalia, California, and you are 36 degrees above the equator. However, on March 21st, the sun is directly over the equator. You are 36 degrees away from the equator. So the people standing on the equator are going to see sunlight at a 90-degree angle, but you are going to see sunlight at a 36-degree less angle. So on March 21st, 90 minus 36, on March 21st, the sun only gets to be 54 degrees over the horizon at noon on March 21st. That's how the solar angle works. It's the same math, everybody, but I'm going to tell you that on December 21st, the shortest day of the year, Visalia gets sunlight at a 30-degree angle. In the summertime on June 21st, it's going to be 77 degrees. So our range of angles is from 30 to 77. We never see sunlight at a 90-degree angle. Because if you somehow try to convince me that you saw sunlight at a 90-degree angle over Mooney Boulevard, I would probably highly suggest you get religion real quick, because it means something really bad has happened in the cosmos and we ain't got much time left. You will never see sunlight at a 90-degree angle in California. It ain't happening. Okay, you're too far above the equator. Okay. I said we go around the Earth, or around the sun, in a slightly elliptical orbit, and I also said that we are farthest away at some time and closer. This is a little bit of vocabulary I need you to know for the sake of the exam, everybody, and it's on the study guide. The first one there is 2B, where it says perihelion. Perihelion is Greek, and it refers to the point in Earth's orbit when it is physically closest to the sun. You're in peril. You're getting close to the sun. Get it? Perihelion. The sun, Earth is on that day, which is, we are closest on January 3rd. We are 91.5 million miles away from the sun. We are closest to the sun. On January 3rd, we call this point in our orbit perihelion. So if you are in discussion with somebody about orbital mechanics and somebody says, well, the moon is at perihelion, what that means is the moon in its orbit around the Earth is physically closest to the Earth. That's what perihelion means. The next one down, 2C, it's pronounced aphelion. It's the exact opposite. It's when you are furthest from the sun, which occurs on July 3rd. And we are 94.5 million miles from the sun. And the reason I'm giving you these distance numbers, everybody, is I'm trying to emphasize that our changing distance has nothing to do with our weather. It's the changing solar angle that matters more about the seasons on Earth. And then finally, I'm going to finish with the 4 seasons.
What was the million miles with the last one that you just said?
Aphelion, we are 94.5 million miles from the sun. You know what else is another freak coincidence of the Earth's relationship in our solar system? We have a 24,000 mile around planet. We go around once every 24 hours. How convenient is that? You're aware of the lunar eclipses that we experience. Occasionally we get a total lunar eclipse. Well, another odd coincidence is the fact that the size of the moon in relationship to the distance to the sun, there's a 1 to 400 ratio, which means that the moon appears to perfectly cover the entire sun. You see, we have a rather odd relationship with our moon as opposed to the other planets, because in relation to the size of the Earth, everyone, our moon is huge. Absolutely huge. If you didn't know any better and you had the ability to get a spaceship and fly into our solar system, you would see a planet like Jupiter. And even though it has 72 moons, everybody, relative to the size of Jupiter, they all look like peas. We look like 2 planets going around each other. That's what makes us odd. The size of our Earth relative to the size of Earth. I mean, our moon relative to the size of Earth. And another just serendipitous coincidence has to do with this, the size of the moon in relation to distance to the sun in the background. It makes a very small moon appear completely blocking out the sun, which we all know is way bigger than our moon. But the distance ratio is perfect for the size of the moon. It's just one of those odd coincidences, because say Mars, for instance, its moon is maybe 20, 30 miles across. That's it. Mars doesn't get a solar eclipse or a lunar eclipse because its moon is not big enough to block out the sun. So we are unique. We're the only planet in the solar system that experiences a total solar eclipse by the moon. Nobody else gets that. So we are very, very unique. Okay, the 4 seasons. Why exactly are there 4 seasons? Because there's no rule in the cosmos that says planets have to have 4 seasons. And I don't mean to offend anybody's faith here, but that's just plain math and physics. The reason we have 4 seasons, everybody, is precisely because we are tilted 23.5 degrees. If you take 90 and divide by 23.5, it's not exactly, but it's pretty close. It comes up to about 4. If we were tilted at 45 degrees, there'd only be 2 seasons on planet Earth. So once again, it's just coincidence that we happen to be tilted at 23.5 degrees. And
from the sun or from the moon? I'm sorry.
What was your question, Michaela?
You said it was tilted 23.5 degrees towards
Earth is tilted 23.5 degrees, correct.
Okay, thank you.
Yeah. I'm sorry, Jack, what was the question? You mean exposure to sunlight? Oh, seasons, because it has to do with where they're located on the planet. Jack, if you live on the equator, you only know 2 seasons. It's either the wet half or the dry half of the year. If you live in the North Pole, you only know 2 seasons. It's either the dark half or the light half of the year. And if you live in the middle, which is where Visalia is located, you get 4 seasons. I was mentioning this to you guys yesterday. In the winter, when it's the shortest day of the year here, it's usually completely dark outside by 5 in the afternoon. And if you were to drive up north, say even just to Seattle, it would be about 3:30 before it got really dark. It'd be almost a full hour and a half before you guys get total darkness. And so as you drive further and further north, the kind of seasons that you experience change. And so this is one of the reasons why this section of material emphasizes your location on the planet, okay? So the 4 seasons are precisely because we are tilted 23.5. And what I am going to go over tomorrow is, I just got through telling you we are tilted 23.5 degrees. Well, common sense, and I'm hoping you're all applying this here in your thought process here, everybody. 23.5 degrees from what? What are we tilted 23.5 degrees from?
The sun.
I will go over that tomorrow. Okay, I'll see you guys tomorrow.
Thank you.
Bye-bye.
Thank you.
Also, if we have any more problems with the recordings, I'm sure many of you will let me know. But if we continue to have problems with the recording, I'll prepare the notes for you.
Are we going to need PDF? Is that going to be the routine all the time? You're going to send the PDF?
Correct, Horace. Yeah, I'll be sending you PDFs and you'll be returning answer sheets to me in the form of a PDF file. Yes. No, Jack, the entire planet is physically closest to the sun in January. And you got to admit that part of the reason I emphasized it is because it sounds contrary to what you would believe. But you have to expand your thinking in terms of the size of the solar system, and you have to realize 3 million miles is nothing. Nothing. When I told you earlier that we have satellites orbiting the other planets, well, that sounds cool, but these satellites take years to get there because they're so far away. So when we want to put a satellite in orbit around Jupiter, it takes nearly 5 years to get there. And our satellites are moving at about 50,000 miles an hour, and it takes 5 years to get there. That's a long way. So 3 million miles in Earth's orbit is nothing. Absolutely nothing. Yeah, the satellite that we sent out and it passed by Pluto in 2015, I think. We launched the darn thing, I think, in 2006. It took about 9 years to get out there. And we had to do some fancy maneuvering to make that satellite move faster than anything we've ever made before. The single fastest rocket we own is only capable of creating velocities in the 25 to 30,000 mile an hour range. That's the fastest thing we have. If we want to go any faster than that, everybody, we have to do what's called a gravity assist. What we do is we aim for another planet like Mars, or we may even shoot our rocket out into space and then direct it to come back toward the Earth. And what we want it to do is to circle around the Earth and then have Earth's gravity slingshot it out into space at a much higher speed. That's how we get our satellites to go as fast as they do, because it's not the chemical rockets that are causing it to move at 50, 60,000 miles an hour. Chemicals are only capable of producing thrust in the 25 to 30,000 mile an hour range. That's it. So we have to come up with another form of propulsion if we want to move any faster than that. Okay, I'll see you guys tomorrow.
Thank you so much.
Recording
Have a good day.
stopped.
Mm-hmm.
Hope you have a great day at work or a night at work tonight.
Oh, I'm sure I will. It's always an interesting crowd at night.
Which hospital do you work at? I thought it was Korea Delta, but it's not, right?
No. I have worked at Kauai about, oh gosh, I want to say 10, 11 years ago. Are you familiar with the staff down there?
Not exactly. My sister-in-law and my sister's mother both are nurses for Korea Delta.
Oh, it's been a while. It's been a long time since I was there. I don't have a private practice, and I was kind of hoping to be retired about now, but COVID prevented me from retiring. But I work for a group, and we're kind of like traveling nurses. What we do is we contract with a hospital as a group. And so there's about 10 of us. And once we are hired by a hospital, we are the night shift, day shift physicians that come and go, for say, whatever, 6 month or 1 year contract, that kind of thing. Because what a lot of people don't realize in this country about our particular healthcare system is that hospitals over the last 20 years have been making a really serious concerted effort to control costs. Mm-hmm. And so any way they can save pennies. And so I joke with some of my colleagues and I say, one of the biggest differences I noticed between now and say the 1990s is that these supply rooms in the various hospitals are noticeably thinner today than they used to be. And the reason they're hiring groups like me, and even nurses do this too, the reason they hire them is the salaries actually sound like they're higher and you get paid better, but you don't get the benefit package. And in the long run, that's actually cheaper for a hospital to do that. So, I don't blame anybody for that. That's the system.
Yeah.
That's the way it is. But yeah, it's all about, and so when you go into an emergency room, if let's say you have a family member who has a chronic illness and you, maybe twice a year, possibly 3 times a year, you end up having to take that person into the emergency room. After a while, you start to begin to get familiar with some of the faces in the emergency room because you've been there several times. Well, with people constantly rotating, don't be surprised if you're gone for 6 months and come back and it's a completely different set of faces. That's not unusual. And as a matter of fact, over the years, I've adapted, I think, quite well to the fact that you have to be adaptable in these new, times. That's one of the key characteristics you have to have about yourself. You have to be able to roll with the punches. So, do I always have the resources available to me? No, I don't. Sometimes I got to improvise, and when hospitals don't have the resources to treat you, that's when you get transferred to another hospital. And then you got to go through that process. And it may sound simple, like, oh, we're going to move you to another hospital.
No,
well,
it's
it's
not.
not. Yeah. You got to get another doctor to accept them. And then you got to make sure that hospital can actually treat whatever it is this person has. Mm-hmm. And so, you have to be very adaptable to it. And it's something I think I've accomplished. I don't get phased easily. I don't get terribly upset or stressed out over particular situations. And it's something I had to learn because I move around so much. Because over the last,
you're moving every 6 months?
Just about. Over the last 20 years, I think I have worked just about every ER in the Central Valley at one time or another.
Oh my
You
goodness.
know,
So you do online only classes then? Because
well, since COVID started, I was actually teaching on the COS campus for nearly 20 years before COVID started.
even though you have to travel around as a doctor?
I conducted both professions at the same time, yes.
Wow.
Yeah.
Wow.
It was busy, but you know, in a way, my kids were teasing me about this because I have such a wide variety of interests that my kids tease me that it's hard to keep up with me because they don't know what I'm talking about. And I said, well, I'm like the dog who gets distracted by the squirrel. That's me. And so, but like I said yesterday, I find commonality between teaching and medicine.
Yeah.
Because the vast majority of my patients really don't understand their illness and they don't understand what their options are, because in large part, they really don't understand how the American healthcare system works. And so, you know, some of the elderly patients don't have an issue with it because they've been through it before and they've learned and they know what to do. But you get somebody in the ER that's only 30 years old and they've got some like kidney disease or something. Yeah, it's a big learning curve for them. They have to learn how to navigate through Medicare, Medi-Cal. They have to learn to navigate through all the various hospitals, how to talk to a doctor, what kind of questions should I be asking, you know, how to interact with the nursing staff, that kind of thing. It's things that these patients learn over a long period of time. And it involves a continuing series of education to keep reminding them, this is what you got to do. This is what you got to do. It's like every time I diagnose a brand new diabetic, you know, you're telling them that, you know, from this point forward, you can't keep eating what you've been eating for the last 35 years. And that's not easy to do.
No.
And, you know, I really do. I equate that to trying to quit meth. You know, you can't eat mom's cooking anymore because it's bad for you. And so these particular patients, if they're not well educated about their diabetes, you know, they're what we call in the ER frequent flyers, because, you know, they think to themselves, you know, that one happy meal ain't going to do it to me. So they indulge. And next thing you know, they're in the ER with blood sugars that are through the roof and they're incoherent. And we're having to give them, you know, a treatment for it is just give them fluids. But we're having to pump fluids into them, give them some insulin, that kind of thing. And if they're lucky, they can get out of the ER in about 8 to 10 hours. Otherwise, if they go into a diabetic coma, yeah, they could be in the hospital for a week or more. Yeah, to get their sugars back under control. And some of these patients, they go through that experience several times before it finally sinks in. I got to make a lifestyle change. Yeah. And, you know, diabetes is an easy example, but, you know, there's people out there who have chronic kidney disease, other people with COPD who continue to smoke, that kind of thing. And, you know, it's education, education, education. So I'm more than willing oftentimes to sit down with a patient in the room and literally just bullshit with them for an hour or two, as long as we are talking about their disease and their treatment. Because oftentimes, and this is another running joke too, is patients for some reason think I'm interested in hearing about their dog, the car they bought last year, and thing, you know, like you're here, you know, you're here because somebody shot you and you got a hole in your shoulder. I don't care about your dog right now, but for whatever reason, they want to talk about it. That happens a lot.
Yeah. Yep. I was going to say, I don't know about the shooting one, but I was going to say like diabetes and elderly, it's because they're lonely.
Yeah, well, we've actually had, you can imagine over the course of anybody, your career, even nurses, you know, they've seen it all. They've seen it all. And what we've seen in the case of the elderly is, especially ones, like you said, who are lonely, they will actually manipulate the 911 system to keep getting brought back into the ER over and over and over again, because they know that once they're in the ER, the staff is obligated to treat them.
Mhm.
You know, even though we know there's nothing wrong with this person, we still have to draw some blood from them. We still have to take their vital signs. We still have to give them a blanket. We still have to give them a PB&J sandwich. We still have to give him his juice. And if he wants to pee, we got to hold it for him.
Yeah.
And they know that.
Isn't that Manchester syndrome though?
He's not projecting it onto anybody else. He or she,
Oh, okay.
they're just looking for the attention. You know, they're lonely is what it is. They're lonely. And the mere act of giving them a blanket or maybe a sandwich and something to drink makes them feel secure, safe.
Yeah.
Trust me, there's nothing going on at their residence. They're just lonely.
Yeah.
And so these particular frequent flyers, we've even got dedicated rooms in ERs. Oh, he's here again. And they go into a particular room that is out of the way.
Mhm.
So that, you know, when somebody who's really sick comes in, then that room's available. Yeah. But we can't turn them away.
Mm-mm.
We are obligated to treat everybody that comes through there, even if they're manipulating the system. And many of them, unfortunately, do. You know, because they know a lot of them treat the ER like a shelter.
Mhm.
You know, if there's bad weather outside, all of a sudden the homeless start showing up in the ER. And why do they go there as opposed to going to a homeless shelter? Many of them tell us that they feel safer in the ER than they do a homeless shelter. And so, yeah, we have to, you know, basically all we do is let them sleep it out overnight. And then at 6 a.m. we're like, you know, don't let my foot hit your butt on the way out the door. But yeah, we have to feed them. We have to give them a warm blanket, and we have to let them sleep on a gurney. So there they are. And so the healthcare system today is all about saving money. In 1995, had you broken your arm, we might have admitted you to the hospital for 2 or 3 days, just to be sure. Make sure your pain's under control. Make sure if you have any dressing changes, we'll take care of that for you. You see, today, if you break that same arm, the moment they put a cast on you, which is maybe 3 or 4 hours later, they're sending you out the door with a script for pain meds and say, all right, come back in a couple of days and have us check on it. So if you were ever to look at an itemized bill of your hospital stay, and I hope you never do, but if you were to actually look at an itemized bill, the single most expensive thing on there is not me, and it's not the CT scan, and it's not the blood work. It's not even the drugs they gave you. It was the room you were in.
Yeah.
And if you're in the ICU, it's all the more expensive, precisely because inside that room, all the equipment necessary to restart your heart and get you breathing again is hanging right there on the walls.
Yeah.
So when you go into one of those rooms, it's the equivalent of renting a penthouse apartment on the Hilton.
Yep.
So I'm guessing place like Kauai, an ICU bed would probably cost you about $3,000 to $4,000 a day. A day. And then there's the drugs, and then there's the treatments, and then there's the staff. Yeah. So.
Yeah, my major was nursing, and I changed it because I don't feel like it's what it used to be.
Oh, it's most definitely changed. I notice now the newest generation of nurses, those young men and women who are still in their 20s, I've even noticed a difference in attitude, and I don't know if this is bad or not, but I seem to remember nurses being a lot more compassionate back then than I do today. It's more by the numbers today.
Yeah.
You know, it's like
I like the patient care and like the bedside manner. That's my what I love. And I'm like, it's not like that anymore. So
you're exactly right. You're exactly right. Because
not like that
a lot of
anymore.
them,
So
unfortunately, too many of them look at the profession like nothing more than a means to an end. That's it. And as a patient, you're nothing more than somebody I'm required to interact with by giving you medication, bathing you, or something like that.
Yeah.
And so, yeah, I see less and less of that. And it's funny you mentioned that because just the other day, I had a young woman who was moving a patient for me, and she was being rather rough with the patient because she was in a hurry. She wanted to go home, and to her, this was it was getting in the way of leaving. So this elderly man with dementia is, shoving him off the gurney and practically throwing him on the bed. And I had words with her afterwards. I said,
I'm glad you did.
yeah, you are in the wrong profession if this is how you're going to think. But anyway, yeah, you're right. I do see a change, and it's exactly what you think it is. So unfortunately, so yeah, it's. I had an experience a few years ago where I had my appendix taken out, and they stuck a drain tube in me, and they made me stay overnight, and they hooked me up to a drip that contained pain medication. And they threatened me with, if you don't get up and pee in the next 2 or 3 hours, we're going to shove a tube up you and we're going to drain the urine out of you. And so I said, all right. So at 2 o'clock in the morning, I wanted to get up out of the bed to go to the bathroom, but I had abdominal surgery. I had my appendix taken out. Now, I am not going to embarrass myself and say I know what it's like to have a baby, but some of you ladies have probably had a C-section before. And when you get the underneath of your abdomen cut open to remove a baby, the next day it hurts like hell because we just cut through all those walls of muscle tissue to get to the baby. And that's what you're feeling, is your stomach feels like Mike Tyson went 3 rounds on it. And well, that's kind of how I felt. So I pushed the nurse call button because all I wanted her to do was grab my hand and get me to sit upright. I will walk to the bathroom on my own. And she walked in the room and she acted like she was about 25 years old, like a total princess, a real diva. She was like, oh no, I can't do that. So she disappears, and about 10 or 15 minutes later, this big, huge football player looking guy shows up in my room. He's like one of their transport people. And he does nothing more than grab my hand and pull me upright. That's what I witnessed. I was like, oh. So I'm planning on, when my expiration date arrives, I'm hoping to be able to do so at home. That's a rather morbid subject, which I hope is a while down the road still. But, based on what I see, the behavior of the staff now, I'm almost like, I don't want to spend my last days in that kind of environment.
I said it's heartbreaking. And
yeah. So, I completely understand those people who have elderly relatives that they're caring for. I mean, it's not easy. It's not easy. So, okay. Does anybody have any questions about the lecture today? No? All right. I'll see everybody tomorrow. Bye-bye.
thank you.
Mm-hmm.